The story of naval warfare in World War II begins long before the first shell is fired. In December 1939, the South Atlantic became the stage for an encounter that would change naval history forever. HMS Exeter, a British heavy cruiser, spotted something on the horizon. Something that would challenge everything sailors thought they knew about battleships and their invulnerability. On board the German pocket battleship Admiral Graf Spee, massive shells waited, each crafted with extraordinary precision. These were not ordinary munitions. They were designed to destroy not only steel, but the lives within, exploiting vulnerabilities in ways that reshaped naval strategy. Understanding these weapons requires an appreciation for the engineering, ingenuity, and sheer brutality behind them. Germany's engineers were driven to solve an impossible problem. By the mid-1930s, battleships had become floating fortresses, their armour engineered to repel nearly any attack. Conventional shells bounced off, leaving crews and strategists scrambling for a solution. German engineers faced an immense challenge: how to penetrate armour that seemed impervious. The answer lay in developing a shell that combined unmatched hardness with enough resilience to survive impact without shattering. The steel used had to be forged under precise conditions, heating and cooling in cycles designed to create a structure not found in nature. Weeks of work went into a single casing, and the men who shaped these shells knew they were crafting instruments of unparalleled power. Each shell represented a fusion of scientific understanding and mechanical precision, engineered for maximum destruction. The explosive power inside the shell was a study in controlled chaos. The shell casing alone was only part of the equation. Inside lay hundreds of pounds of highly volatile explosives compressed into a space smaller than a trash can. These compounds were engineered to detonate precisely at the moment of greatest effect, a process made possible by advanced delay action fuses. These small mechanisms had to endure the force of being fired, strike the armour of a moving ship, and then detonate deep inside. German Type A fuses accomplished this through a combination of mechanical and chemical engineering, ensuring that the explosion would occur exactly when intended. The timing was critical. Too early and the shell would fail to penetrate. Too late and it would pass through harmlessly. The destruction caused by a single shell was almost unimaginable. When HMS Hood engaged the Bismarck in May 1941, the devastating potential of these weapons became horrifyingly clear. A single shell penetrated the deck armour, detonated in the ammunition magazine, and destroyed the ship almost instantly. Out of a crew of over 1,400, only 3 survived. The combination of kinetic energy, explosive force, and the careful engineering of the fuse turned each shell into a mobile arsenal, capable of triggering secondary explosions that, really magnified its destructive power. This is where the true ingenuity of naval artillery becomes apparent. Shells were not just designed to punch through armour, but to exploit the internal vulnerabilities of the ship, maximising chaos and, casualties. The physics behind armor penetration was actually far more complex than most realize. Penetrating battleship armor was not simply a matter of brute force. The shell's velocity, its shape, and the angle of impact all determined whether it would pierce steel or just shatter, really. Germans developed these dual-cap designs, where a soft armor-piercing cap cushioned the impact, preventing shattering, while a ballistic cap, improved flight stability. When the shells struck, the ballistic cap crumpled, and the armor-piercing cap allowed the hardened body of the shell to push through, forcing steel to deform and tear in a controlled way. Similar engineering innovations were mirrored in American and Japanese shells, each approach fine-tuned to maximize penetration and internal damage. Understanding this level of detail, honestly, illuminates the intersection of human ingenuity, material science, and military necessity during the war. Engineers kept refining their shells even as the war shifted. By 1943, the focus had shifted from sheer penetration to fuse reliability and explosive efficiency. Engineers experimented with combination fuses, base detonating mechanisms, and even small rocket motors to optimize range and detonation timing. The results were honestly devastatingly effective. 8 out of 10 shells would explode precisely where intended, increasing both strategic and psychological impact. In some cases, shells incorporated incendiary compounds such as white phosphorus or thermite to create fires impossible to extinguish, ensuring that survival after a hit was exceedingly unlikely. These designs were not just about technology. They were, calculated expressions of destructive strategy, blending chemistry, physics, and mechanical engineering. Even in defeat, these innovations influenced post-war military technology. By the end of the war, battleships themselves were becoming obsolete, replaced by air power capable of bypassing armor entirely. Yet the engineering principles developed for naval shells, delicate fuse timing, shaped charges, controlled penetration, would inform artillery and missile design for decades. The men who designed and loaded these weapons may be gone, but their work continues to shape how militaries understand the lethal combination of precision, timing, and physics. The remnants of these shells, preserved in museums or lying on the ocean floor, serve as enduring reminders of human ingenuity applied to destruction. The story of World War II naval artillery is not just about battles and statistics. It is really a study in the extraordinary lengths humans will go to achieve strategic dominance. Every shell is honestly a testament to engineering excellence, extreme risk, and, moral complexity. For enthusiasts of history and survival alike, understanding these weapons reveals the interplay between technology and human decision-making under conditions of life and death. If this deep dive into the hidden truths of naval warfare fascinated you, go ahead and subscribe to the channel for more stories that uncover the engineering, strategy, and survival lessons of history. And, share this video with fellow history buffs who appreciate understanding the true mechanics behind events that shape the modern world.